So when I walk into my grade 6 classrooms, the students are really excited to see me. I don't bring them pizza, I don't let them go out for recess early, and I don't watch movies. I do math with a focus on Aboriginal youth as part of an outreach program for the Department of Math and Stats at the University of Saskatchewan, and the students call it Math Day with Stavros. Now, I wish when I walked into my university calculus courses that the students were just as excited to see me, but I'll take what I can get. So why are my grade 6 students so excited when I come to do math? Well, I teach math in a way that accommodates their experiences and backgrounds and challenges forms of oppression in the classroom. It's anti-oppressive math education. My activities start with a colorful PowerPoint usually, for example, something about nature. And we have a discussion about Indigenous knowledge and the deep-rooted connection that Aboriginal people have with the land. Usually I'm co-teaching with an Aboriginal teacher, and so that teacher shares their narratives. Once the students get warmed up, I get them thinking mathematically. So I'll ask the students, what sort of branching pattern do you notice on this fern leaf? So the students will excitedly give me all sorts of answers, but in particular they notice that smaller portions of the leaf resemble larger portions of the leaf. We see this repeated branching pattern in our lungs, for example, and in lightning. In general, patterns that repeat are known as fractals. Fractal patterns are pervasive in nature, and we're more connected with them than you might know. For example, how many of you, when you're bored in a meeting or you're on the phone with someone, you doodle on the side of your paper? Yeah. So what sort of images emerge from the doodling? Well, a lot of people have symmetrical patterns or patterns that repeat. So take this tree, for example. We can see that the branching pattern looks very simple, but as we go towards the top of the tree, it becomes very complicated. So I just asked my students, can you give me a simple description of the branching of the tree? So the students will say, well, it looks like the branch splits into two, it makes a V, and then those branches split into two, and then those split into two, and so on. So in the first stage, we have 2, and then 4, and then 8, and then 16, and then the students don't need to count anymore because they can predict there will be 32. So the students know that we're doubling or multiplying by 2. Now, depending on the age group of the students, we can bring in other concepts. For example, on the layer where you'd have 8 branches, that's 2 times 2 times 2. So rather than writing a 2 times itself 3 times, we can write it 2 to the power of 3. So in a natural way, we can bring exponents into this topic. So why do I teach math in this way rather than just pulling out the textbook and asking them to follow along with me? Well, the fact is, a lot of students don't connect with this Western style of teaching, meaning that a lot of students feel disconnected in an environment where they are just passively sitting in the classroom and a teacher is standing at the front just putting facts in their brain. These ideas enter their brain and they're inert ideas. They don't react with their daily lives. So mathematical ideas will just stay in their heads, but it doesn't ever get integrated into their daily lives. You get this disjointness of ideas. So a little more generally, in the area of math achievement, particularly if you look at the research about Aboriginal math education, the story starts with statistics. So it'll say, statistically, Aboriginal learners perform poorly on all forms of math assessments, but in particular, Aboriginal students perform worse than non-Aboriginal students. It doesn't give a whole lot of an introduction to that. It just kind of states it like that, and it will often just attribute it to, it'll say, cultural differences. And then other research will say that Aboriginal learners are, it'll say, disengaged because there's a lack of applicability and relevance with mathematics. But I mean, sure, that's true, but I mean, this is a problem in general, not just for Aboriginal students. Non-Aboriginal students need applicability too. So it seems like the research is starting on chapter 2, like something isn't being said. So what is chapter 1 of this story, and how can we write this story so that it has a positive ending? Well, the answer to that comes from a loaded term that I used earlier, anti-oppressive math education. So in a Canadian context, this means that the story starts by acknowledging colonization. So when the Europeans came over and settled, there was contact with the Aboriginal people, and it didn't go well for the Aboriginal people. And I think a lot of us like to think, oh, that happened a long time ago, like it shouldn't really be relevant or it shouldn't matter, but the fact is that it does matter, it is relevant, and it actually didn't happen that long ago. For example, the 60s sweep. So while my parents, this is in my parents' generation, while my parents were at home with their families, Aboriginal children were being taken away from theirs. And Aboriginal children were placed in institutions like residential schools. The purpose of a residential school was to force Aboriginal people to forget about their culture, their history, their language, to forget about who they are. So, I mean, these are completely the reason why we have disparity in education, healthcare, other places, for example. So when we add these social issues to the fact that in general, Aboriginal knowledge, Aboriginal ways of learning and knowing are different than Western knowledge, Western ways of knowing, we get a conflict in the math classroom. One of the schools that I work in has a high Cree population. And a lot of the teachers are also Cree, and they impart this knowledge, like their language, for example, to the students. So I wanted to legitimize this learning when I started working in the classrooms, meaning that I wanted to say that it is valuable and important to incorporate Cree in mathematics. So I thought, how can I do this? Well, I came up with just a very simple activity. It's just multiplication bingo, but the students are encouraged to talk about the numbers. We're talking about primes, composites, factors, multiples in English and in Cree. So this is exciting for students for a number of reasons. I mean, first of all, they're playing a game, right? So half the time they don't even know they're doing math. But more importantly, it's a chance for a mutual exchange of information and knowledge. So I come and I have something to share. I'm teaching them math. I don't know anything about the Cree culture, so that's an opportunity for them to share something with me. Now, one student in particular, he's very withdrawn. He's not a troublemaker or anything. He's a very nice boy. In fact, he's always really excited to see me. He always comes up and gives me a hug. And he's always curious to know what we're going to do for the activity. But when he sits in the classroom, he doesn't talk. He doesn't answer questions. He doesn't want to write anything down. He's just very disconnected from everybody else. He just sits in the classroom very quietly. So when I came in the classroom and I said, okay, we're going to do this activity, but I need you to teach me the Cree numbers. Well, this student just came to life. His hand shot up in the air and he was like, oh, Mr. Stavro, I know what the numbers are. And he started to say them for me, and I was writing them down on the board. And he was teaching me how to spell them. He even knew where the accent signs go on the letters. So the numbers 1 to 10 are there, and you can see the first three, piak, niso, nisto. And I mean, this is a big deal because, I mean, if you just look at the language, it's actually a very complicated language, and it's because Cree is a descriptive language, so a lot of information is encompassed in these words. So when he felt acknowledged and he felt like he had something to offer and something to share, he felt valuable, he felt important, and he wanted to connect in the classroom. So a lot of people ask me, what is Aboriginal math education? Like, what do you do all day? And I think there's a common misconception that people think I'll be like in a cave deciphering ancient hieroglyphics or something, or I'm in the wilderness talking to trees, I don't know. And okay, in fairness, when I first started and I was thinking cultural mathematics, I did kind of think that. But no, Aboriginal math education, what it means to me and what it means to these students is a collaboration. It's a collaborative process between a Western knowledge system and an Indigenous knowledge system, and finding ways to connect them in the classroom so that you can legitimize the history and narratives and the language and the culture of Indigenous people so that you can give a voice to these silenced cultures, to these silenced people. Because math education is something that should be accessible to everybody. Thank you.